let's move on to the next demo. So persistent storage, what do I mean by that exactly? So we've just exported data from our simulation to a CSV file. That means an extra file that we need to keep track of potentially. And that sometimes can be problematic in certain situations. So what we want to explore here is, would there be a way of storing this data directly in the NX file instead? So let's have a look. The answer is yes. The answer is always yes. But let's have a look at what we have here. So this was a Python module that was developed by a colleague of mine. His name is Etienne. I'm going to come back to him a couple of times, so that way we all know who we're talking about. And what am I trying to do here? Okay, I'm going to open this part here. It's a special part. This is supposed to be an egg. Etienne is a very good developer, not much of a modeler. But so anyway, this is what it is. Etienne is basically the lead NX Open guy at Maya. He also gives the trainings for NX Open, but unfortunately could not be here today, so I'm here instead. So you get not the second best. You get something else instead. All right. So he's developed a module that he called NX embedded file that allows us to basically store anything we want in an NX file. And that's very, very useful and very interesting in what it can do. It uses underneath, I don't know if you're familiar, but it uses user-defined objects in NX underneath to store these things. To store data, to store personal data in a file, you have basically two options: user-defined objects, or you have attributes, either part attributes or model attributes. The attributes, however, are not nearly as flexible as what the UDOs, user-defined objects, are, and they don't provide as much, all the functionality that we would need. So for example, we would want this data to potentially be private, not being able to browse it. We want it to be able to perhaps handle large arrays of data, for example. And all of that can be done by the UDOs, not necessarily by attributes. So there's a little script I'd like to call that's basically just listing files and list files in part. I'm going to run this, and I'm going to see this one I can make bigger. All right, and then I'm going to go through the code afterwards. But basically, this is telling me there's actually 3 files embedded in the file itself. There's a JPEG file, there's another part file, and there's also some quotes apparently from Yoda. So let's go see what the code looks like here. And so this is really bugging me in terms of size. So I'm going to try to appearance. Okay, so it's control. Is that better? Yeah, I think it's gonna look a bit better. So let me bring up that file that I just ran. And basically, it starts like most other. If you've ever done any journaling, basically you need to first get a reference to the part that you're working on, and you do that using you get a session for NX, and then you can use parts.work, for example. And this is the W2W function that Mark was referring to before. It basically writes to the window, to the listing window. And we're using then this module called NXEF, which was developed by Etienne. And it queries using this functions, NXEF by name. And you'll see like all of the Python code that we have here, by the way, just a little side note, has these doc strings that we call. So they're basically embedded documentation for every function. That's actually part of the language itself. And what it does is in an environment like VS Code it will know about these things, and it will bring them to you on the screen directly as you're typing, as you're developing, and things like that. So that's very, very useful. And so we're just basically iterating over what this list of NXEFs by name that are stored in this part, and we're displaying them. Simple enough. Okay, so let's see what we can do here with that. I'm gonna switch gears a bit, and I'm gonna go to a debug console instead. So I'm gonna go to this start debug file, and I'm gonna launch my debugger, my debug session. So this is live debugging, no wire, no harnesses. Hopefully I'm up to the task. Okay, so let's see. So this is the same kind of output that we just saw. Right, so what could I do here? I have a few functions. So there's that list function is there, right? It's called list embedded files. This is what we're just called there. Okay, that's fine. So let's see what we can do with let's say Yoda's quote. I'm kind of curious to see what's there. So I created this function that allows me to read an embedded ASCII file. I'm assuming those quotes are in ASCII. Of course, they are. And so what this does is it, using, again, the NXEF module, it opens this file and it basically returns the lines of this file as a list of lines, basically. So I'm going to do, you know, Yoda's lines are equal to read embedded ASCII file. And I need to read that from my work part. Or actually it's called first part in this case. Yeah, first part. And the name is basically what's written there. So Yoda's quotes. Again, so in a debug session, no output means good news usually. And so what I can ask and then just display what you have there. Oh, there you go. So it's a list of strings. So if I display the first one, then I get mind what you have learned, save you it can. Very wise, Yoda. And then if I can look at the second one, master NX open, you will. All right, so this is good. So I'm not going to keep going here, but you can see, so this is data that was stored in the NX part file directly. Now, some could question just how useful Yoda's quotes would be in the NX part file, and you'd be right. It's not very useful. So let's list again what the embedded files are in here, just to be reminded. There's a JPEG file, there's a part file. So this is just to illustrate that really you can store anything you want. So strings, you could have stored that using attributes, right? But a JPEG file using attributes, probably not. So let's just see, I have a function that basically writes an embedded file to disk. So what this thing does is fairly simple. It opens the file as a binary file, reads all of its contents, and basically then writes it back to a disk, to another file that I provide the name of. So let me just do write embedded file. I do the first part, and it's let's go look at that picture. Remember, this is in the spirit of Etienne not being here. I'm assuming this is not my mom and my dad. I'm pretty sure. And then I'm going to call that data/picture.jpg. So I don't have to actually name it the same thing. And then doing that tells me, okay, you've written that many bytes to this file. Let's go have a look. So sure enough, now I have a picture.jpg file here. Yeah. And if I open it, yep, it's a picture. And this is, ladies and gentlemen, Etienne in his glory when he was 1 or 2, I can't remember. He didn't tell me, but basically, yeah, you can save binary data to a part file as well if you want. Very nice. So I'm gonna, there's also a part file. I'm kind of curious to see what this is. So first part, and this time I'm gonna specify babushka. Medium, okay, dot part, and I'm gonna save that to data dot part, okay. And sure enough, I should have a new file now in here. Correct. All right, so let's go see. Is it an actual part file? It is. So what I could do is then fetch it from here. And it basically, let me show you something. Let me see through all. But basically, I think it's this guy I need to select. Click OK. Sure. So I just added Babushka 1. I don't know how to pronounce this. Babushka. To this file. Oh, there it is. I didn't insert it properly. But basically, it's been nicer if I had inserted it inside, right? That's sort of the idea. But anyway, it's a valid part file. I can add it as a component or anything like that. Now, I'm not suggesting start storing your components and assemblies as binary files in another file. That's not a good idea. That's not how you should do that. It's just to illustrate that we can do pretty much anything we want with this kind of module. Now, to something a bit more useful, I find. Let's just go see in here what we had. Yes, I created I hard-coded a bunch of data here, and I'm gonna just create something. Oh, sorry, node data is equal to generate. So I have this function that this is like a cooking show. I got a function that generates this data for me, and now it's stored. It's a dictionary in Python, like a map in C++, for example. And I have basically, it's a node index with some node coordinates mapped to it. So if I do node data of 20, for example, then I get these coordinates, 11, 12, and 13. If I do node data of 40, I get 31, 32, 33, and so on. So that's my node data object that I created in Python. So this could be any data that I want to preserve in the file, for example. And what I can do now is to actually store this variable in the file and embed it effectively in the part file directly. And how I can do that is by using something called, I have a function called embed data. Let me just bring up another file that I want to show here. Okay. I have this module that I created. It's called embed data utils. So I'm using a module in Python that's called Pickle. Don't know if you're familiar with it, but Pickle basically allows you to serialize any Python object and to store it to disk, for example. So by using that, I can effectively serialize my container of data that I created in Python and store it to the file, and I'll be able to fetch it later on. So let's call this function, and you see it's very straightforward. I basically open a new file in the part file using this NXEF module. So it's on purpose. It was made to behave exactly like actual files, real files. It's just that now they're stored in NX. And I'm going to embed that into the first part here, which was my initial model part that I had open, and I'm going to call it my node data, and I'm going to save node data as the object. So what's it going to do is it's going to call the Pickle module in Python and just basically dump that to the file directly. Done. We're good. So what I can do now is let's see, if I list the embedded files in first part, what I now see is I have a new entry there. It's called my node data at the bottom. So let's my other node data. Let's create a new variable, and I'm gonna read that back from the file here. So read embedded data, which is also defined in this utils here. And what it does is it opens an existing file in using the NXEF module, and again uses Pickle to just load the data. And it should return a Python object the same way that it was stored. Little caveat, it needs to be a Python object with your basically plain old, what we call plain old data. So if you have complex classes, things like that, that you've created yourself, that won't necessarily work with Pickle. But if you have a container that's just, strings, floats, ints, pointers, these kinds of things, it should be able to just save them. I said pointers, but this is Python, sorry. Forget I said that. So I'm going to read that from first part here, and I'm going to give it the name of the data, and it's basically, I'm setting this new variable to this thing. And again, no news is good news in this case. So let me just print out what this contains. And you see that we're back to the same kind of data that we had. If I do the MITRE node 20, again, we get back the coordinates 11, 12, and 13 as before, and 40. Do that. So that's more what we wanted to explain here. So it's nice that you can save files. It's a nice little trick. But really what the important thing, or I think the useful thing here, is that you can store the data that you generate in a Python script, or in a Python script in this case, so that it is persistent. The next time you will open that file, that data will be there, and you'll be able to fetch it. So whether it's data that your dialog requires to function properly, or whether it's results data, or maybe like filtered results that you extracted, kind of like what Mark was doing in the previous demo, you can actually save that in the file if you want. So that's basically the point that I wanted to explain here for this particular demo. So just to finalize this particular topic, am I good on time? Yeah, we're doing okay. So for persistent data storage, this can be used by custom tools to retain information between the different sections. So you close the file, you reopen it, the data is still there, and it's in the file. Now, you could, of course, save that to an extra file, and then make sure that your custom tools actually fetch this data from this particular file. But now there's another file you need to track. You have your part file, you have your results file, and now there's another file that needs to be moved around with all of these things together all the time. Of course, if you're in a PLM setting like Teamcenter, then most likely you could configure Teamcenter to also store these files, and you'll be able to retrieve them and everything like that. However, this is extra configuration that's needed for your PLM system. And very often, like the team that customizes, configures the Teamcenter is not really the analysis team or the modeling teams. And so this is a simple way to track additional data in Teamcenter without any extra configuration. Now note that I'm not suggesting you save all your simulation data in your part file. If you have 250 gigabytes of results from a CFD run, do not save it in a part file. There's a reason why full results files are in separate files, right? Like there's a reason for that. But certainly there are use cases where it'd be very useful to keep that. And using the Pickle module, any type of data can be stored in the file effectively. Just a little side note, I like to highlight a few things about Python because we like it quite a bit, and this is my Python tutorial section. So I wanted to talk about something that's called duck typing, and this is not specific to Python. If you do programming, I'm sure you've heard of it. But basically, it's a saying that goes like this: if it looks like a duck, it swims like a duck, and it quacks like a duck, then it probably is a duck. What does that mean in terms of programming? It means that we can have the nature of a class, a class in the programming language, be determined by its ability to respond to some function calls or to have some properties, instead of having to actually be defined by its interface that I've hard-coded in advance. So for example, if I have an object that basically has a function called quack, and that's how I determine if it's a duck, then any class that has a function quack is effectively a duck from a Python point of view. You could pass that to any other function and it would just be able to say, well, this class dot quack, and it would be determined like it's a duck in that point. What this means really is it means that you get automatic interfaces using languages like Python. The same concept can be done in C++, for example, but then you go into templates and you go to things are a bit heavier in terms of getting to that result in the sense. And you'll have noticed that the NXEF module that we just showed basically used that concept to behave just like a file does. So we were using the exact same kind of mechanism to open and read files in Python as we were for the NXEF module. And the reason for that is that it basically added all of the functionality that a file class has in Python and added that to its module. And by doing that, then you can use it just like a file. So that's really powerful, and it's so simple to use. I really like that particular thing. All right, next one. Mark, you're back here. So we're going to see how we could tie the loop a bit with everything we've shown so far.